Hello everyone. In the last video, we discovered the geometrical definition of a parabola, and we came up with a geometrical equation of a parabola. What we discovered, let's go ahead and write it up. What we discovered is that if we have a parabola, we'll draw a couple different pictures here. Okay, let's say here's our focus. Okay, here's our directrix. Okay, the distance from here to here is P. Okay, we have that the equation of a parabola is going to be x squared is equal to 4py. Now for this specific picture here, this is when p is greater than 0. This is when p is above the directrix. Okay. But another form that we can get is what if p is below the directrix? So let's say this is the what if the focus is below the directrix? Okay. So this will be p. This will be p. I guess this would be, you might say, the absolute value of p if we're thinking about terms of physical distance. Okay. We'll have this parabola here. In this case, this will still be the equation x squared equals 4py, but when the focus is below the directrix, p will be negative. Okay. Well, we don't always have to have a happy face parabola or a frowny face parabola. We could have parabolas that open up to the left and open up to the right. So we didn't always have to draw the directrix being a horizontal line. What if the directrix was a vertical line and we put the focus on either end of there? Okay, well that means the parabola would open up to the left or open up to the right, depending on where the focus is in relation to the directrix. Okay. We could also have the directrix be a vertical line. Okay, and this would be where the focus is. Okay, we'd have this parabola. The distance from here to here will be p. Okay, from here to here, I guess will also be p. Okay. Well, what would be the equation of this picture here? Well, what's the main difference between this picture and this picture if we think about it? Well, one thing to think about is, well, we took this horizontal line, and made it a kind of like a vertical line. I guess the key thing to notice here is that these are reflections of one another over the line y equals x. If you take this picture here and reflect it this way, you're going to get exactly this picture here. So the only difference between this picture and this picture are that the x and y values are switched. This one, the equation here, is going to be y squared is equal to 4px. So when you flip-flop the x and y values, that just flips your axes. So that's why we have this picture here. So if it's y squared equals 4py, it's going to be a sideways parabola. This will be the case where p is greater than 0. That means that p is to the right of the directrix. Or we could also have the focus be to the left of the directrix. So we'll have this parabola here. Okay. The distance from here to here will be p. We'll say the absolute value of p. This is the physical distance. But this equation, the only difference is now since p will be to the left of the directrix, p will be negative. It's, again, just as if I reflected this picture here over the line y equals x. So this one will be y squared is equal to 4px. In this case, for this picture, p is less than 0. So whenever we're looking at the equation of a parabola, instantly we should be able to tell which one of these four pictures we're in, which will be important to us. And one of the first exercises that we're going to do is we are going to graph parabolas. Okay, so a few things that we need to know about a parabola, what uniquely defines a parabola, specifically one where the origin is at 0, 0, is we need to know what the value of P is. That's a key feature. But we'd also like to know, because of what the value of P is, kind of how wide is the parabola? How wide is it? Well, let's try to think of a nice measurement that would tell us how wide it is. Well, for any of these pictures here, what I would like us to think about, let me get a different color, to be blue, is let's say we start at the focus and we travel horizontally till we hit the curve. From here to here. Okay, I want you to pause the video and I want you to try to think about what is the length of this line. Okay, let's do it. Well, if we're using the definition of a parabola is the set of all points that are equidistant from a point called the focus and a line called the directrix. So maybe it's hard for us to know what this distance is, but because it's a parabola, this distance is equivalent to this distance. So these two distances are the same. So what is this distance? Well, here's 1p, here's 2p. This distance here is 2p, so that must mean that this distance here must be 2p. Also, because the graph is symmetric, I guess we could think about it like this. If we were to travel this way, and we wanted to know what this physical distance is, well, that's the same as this distance right here. Well, if this distance here is 2p, then this distance here is also 2p. This is one reason, again, why parabolas are symmetric about the y-axis. So there's this kind of nice measurement that we could make here. That's the distance from here to here. So if you were to take a horizontal line and kind of have it run through the focus and have the endpoints of the line be on the parabola, this length right here is going to be 4p. And another thing to think about is, I guess not necessarily another thing to think about, but this line right here does have a special name. It's called the focal diameter. The focal, let's write it right here, the focal diameter is equal to 4p. The focal diameter is the length of the line that goes through the focus and its endpoints are on the parabola. And the focal diameter is equal to 4p, which is kind of cool because that piece shows up in the equation. Okay, so when we are given the equation of a parabola, what do we need to do to be able to graph it? Okay, specifically if we're given the geometric definition of a parabola, how are we going to graph it? Okay, so I kind of have a set of steps that you should always do when trying to graph a parabola when we're given its geometric formula. I would say that the first thing you should do is recognize orientation. Okay. If it's a x being squared, if it's x squared, that should be kind of familiar to how we're normally used to seeing parabolas. X squared will either be a happy face parabola or a frowny face parabola. Okay? If it's something that's being y squared, so I'm going to write that here. If you see something like x squared, that means it's either going to be happy face or frowny face. If you see something like a y squared, okay, that's going to be something that's either a parabola opening up to the right or it'll be opening up to the left. Now, which situations that we're in will depend on the value of p. So this one right here is when p is greater than 0. This one will be when p is less than 0. This one will be when p is greater than 0. And this is when p will be less than 0. So the first thing you should do, and you should be able to recognize pretty quickly which one of the four shapes that we're in, or what will be the orientation of the parabola, up, down, left, or right. Okay, the second thing that you're going to need to do here is once you recognize the orientation, you need to figure out what the value of P is. P really does define the parabola. So you need to be able to find P. So I don't necessarily know if these steps are in order. You might want to find P first and then recognize the orientation. Regardless, you need to do these two things. Okay, the third thing that you're going to need to do when you're graphing these is you're going to need to I guess what I should say here is when you're graphing the parabola, you need to know the orientation. For the x squared equals to 4py, will always, for these situations, the vertex will always be at the origin. So you'll want to label focus. I guess you'll also you're going to want to label the directrix. Okay, and by knowing the value of P, you should be able to do this. And knowing its orientation, you'll know whether the line is vertical or horizontal. And by knowing P, you'll know which side of the directrix the focus will be on. Then you're going to want to label the vertex, and you're going to want to also label this part. So notice just writing these right here doesn't really tell me everything about the parabola. I also want to know a little bit information about kind of the width of the parabola. You're going to label the endpoints on the focal diameter. Label endpoints at the ends of the focal diameter. Okay, so this is what we need to be able to graph a parabola when it's written in its geometric form. Okay. Soon, when we're labeling the vertex, not too long, we're actually going to move the vertex away from the origin. Okay, let's do some examples of graphing parabola when they're in their geometric form. So let's say that we want to graph, how about x squared is equal to 8y. And in this case here, we should remember that the equation of a parabola is either x squared equals 4py, or we have that y squared could be equal to 4px. Okay, right off the bat, I see something that's an x squared. So I know in this case, the parabola is either going to be smiling at me or frowning at me. Or smiling at us and frowning at us. Okay, so I know its orientation. It's one of these two here. You might be able to see that the p-value must also be positive. I'm expecting to have a happy face parabola for this example. Okay, now that we know the orientation, it might be nice for us to think about what the p-value is. Now, there's a couple ways you could do this. Kind of matching pieces here. I see an 8 next to the y. Here I have a 4p next to the y, so you could think about factoring a 4 out of 8. So if you'd like, you could say this is x squared, and this is 4 times 2 times y, so you might be able to see that p has to be 2 in this example. Okay, if you didn't like kind of factoring that 4 out of the 8, what you can always do is take the coefficient, I guess in this case the coefficient in front of the y. We know that 4p, matching the pieces, 4p must be the same thing as 8. You could divide both sides by 4 to get that p must be 2. Okay, pretty much we're ready to start graphing. All right, so P is 2. That means we're going to go up 2 units from the origin. So 1, 2. So this is where our focus is. So maybe I'll put an F there. Maybe it's nice to label the coordinates of the focus. So the focus has coordinates 0 and 2. Let's draw the directrix. So we'll go 2 down from the origin, or maybe I should say 2 down from where the vertex is going to be. So here's the directrix. Okay. In this case, the directrix, what will be the equation of this line? It'll be y equals -2. since this coordinate here is -2. The horizontal line y equals -2. Okay, so we know that this point will be on the parabola. This is where the vertex will be, again, because, well, the distance from here to here is 2, from the parabola to the focus is 2, and from the parabola to the directrix is 2, so this is a point on the parabola. Okay, now I need 2 extra points to understand or to figure out how wide this parabola is. And that's when we're going to want to look at the focal diameter. So I know if I go out this distance, well, the distance, if I go out, let's see, the distance from here to here is going to be 2p, or the distance from here to here is 4. So we could go out this distance here 4. So 1, 2, 3, 4. So here is 4. Okay, I know that this point will be on the parabola. The point 4, looks like 4, 2 will be on the parabola, because the distance from here to here is 4, and the distance from here to here is 4. Now I'm just going to go to the other end. Here's -4. This will be another point on our parabola. And now we're just going to connect these 3 points. So this is the point what? -4, 2, and here we have our parabola. It might be nice to note what the focal diameter is, so maybe I'll just denote that as the focal diameter. Well, the focal diameter is going to be equal to 4p, so that's 4 times 2, which is equal to 8, but knowing the equation for a parabola is x squared is equal to 4py, you could almost just look at the coefficient in front of y to figure out your focal diameter. Okay, let's do another example. Let's say we want a graph. How about y squared is equal to a -12x? Go ahead and pause the video and give this one here a shot. Okay, let's do it. Let's first try to think about which orientation we'll have here. Well, I'm seeing a y being squared, so that's going to be a parabola that opens up to the left or to the right. Let's see, this is I'm sorry, to the right or to the left. Okay, and so it's going to be one of these two. Which one is it going to be? Well, there's a negative value here, so it actually should be opening up to the left. Let's try to think about what p should be here. Here we're in the situation y squared is equal to 4py. So you could either think about factoring a 4 out of -12. So let's see, we'll get a 4. Well, 4 times -3 is 12. So we can kind of read here that p should be equal to -3. Or if you don't like doing that, you could take this -12, and you know that the -12 has to be the same thing as 4p. And you could divide both sides by 4 to get that p will be equal to -3. Okay, we're ready to start graphing. Okay, so p, this is saying that we need to go left 3 units from the origin. So 1, 2, 3. Here's -3. This is where the focus will be. So here's the focus. Maybe I'll move over here a little bit. This is the focus. And it'll have coordinates. Looks like -3 and 0. Okay, the directrix will be now a vertical line. The coordinate here is 3. Okay, here's the directrix. Okay, and what will be the equation of the directrix? Well, this is a vertical line, so it's going to be x equals. It's going to be x equals 3. This says no matter what y is, the x value is always 3. Okay, we're pretty much ready to start graphing this. Okay, so now we just need to mark kind of the ends of the focal diameter. So this value here, the p value is -3, or the absolute value of p is 3. So we're going to want to go up 2p this direction, so we'll go up 6. 1, 2, 3, 4, 5, 6. So here's 6. 1, 2, 3, 4, 5, 6. Here's negative 6. These 2 points will be on our shape. Again, because the distance from here to here is 6, and the distance from here to here will also be 6, so these points here will be on our parabola. Okay, this point will also be on our parabola. Again, this distance here is 3, this distance here is also 3. So now, we have our parabola. Let's label these points. This point here is negative 3, 6. And this point here is negative 3, negative 6. Okay? Guess it's good to note here the distance from here to here. This distance here is 2p. I should say, if we're thinking about distance, the absolute value of this, which will be 6. Distance from here to here will be 6. So I hope you see here that the focal diameter, which is 4p, I should say the absolute value of this, in case p is negative. Focal diameter is a physical length, so we'll do the absolute value. That should be 12. Okay. Let's do another example, or let's do another exercise. So let's say that instead we're given a little bit of information about the parabola and we just want to come up with this equation. Okay. Now find the equation of a parabola, okay, that has vertex. Let's say the vertex is at 0, 0 and satisfies the following. Okay, so for example one, okay, let's say we're given that the focus is at coordinates 0 and negative 1/4. Go ahead and pause the video and see if you can come up with the equation of a parabola with the vertex at 0, 0, and this is the coordinates of the focus. Okay, let's do it. It might be nicer to draw a picture. Okay, where is the focus located? Okay, what we really want to do here is try to figure out the orientation of this parabola. Okay, well, the focus has an x-coordinate of 0 and a y-coordinate of negative 1/4. So here's negative 1/4. This is where the focus is. So the focus is at coordinates 0 and negative 1/4. Okay, that means that the directrix will be up here. And while we don't know, we might need it. What would be the equation of the directrix? Well, if this distance from here to here, or if this coordinate is negative 1/4, this coordinate here will be 1/4. So this will be the line y equals 1/4. Okay, so from here, to figure out the equation of the parabola, first off, we know that this is going to be a frowny face parabola. So I'm not drawing it super precise. It's not asking us to graph it. It's just asking us to find the equation. So this will be something of the form x squared equals 4py. And in this case, we should know that p is negative because the focus is below the directrix. Now all we have to do is figure out what the value of p is. That's this physical distance right here. The value of p, well, the value of p here, or at least the absolute value of p, will be 1/4. And again, since p is below the directrix, p will actually be negative 4 in this case. We can almost read it. The focus if the origin of if the vertex of the parabola is at the origin, the formula for the vertex will either be 0p or it could be p0, depending. This would be the situation where the parabola is up or down. This will be the situation where the parabola is either left or right. So the p-value here will be -1/4. So p, you can read it from right here, p is equal to -1/4. Okay, putting all the pieces together, we have that x squared will be equal to 4. Our p is -1/4. Y, so we'll have that x squared is going to be equal to -y. Here is the equation of the parabola. Let's do another one. Let's say the focus is at, how about 5, 0. So this is our second example. Go ahead and pause the video and try graphing this parabola here. Okay? Okay, let's do it. You don't have to draw a picture, but I find drawing a picture helps me. Okay, let's figure out where the focus is at. The focus has coordinates 5 and 0. Okay, so here's our focus. 5 and 0. Our directrix will be over here. Okay, this is the vertex. Okay, I'm not going to draw it precise, but we know that the vertex, we know that the focal point will always be inside the parabola. So I know that the parabola is going to open up to the right. So right off the bat, we know that this will have the equation y squared is equal to 4px. Okay, and since the parabola is opening up to the right, or since the focus is to the right of the directrix, we know that p will be positive, and in this case here, p is going to be 5. Let's write the equation of the directrix. The directrix here will have equation x equals -5. Okay, p is going to be 5. We can just plug that into our equation. So we have y squared will equal to 4. Our p is 5 times x. So we'll get y squared is equal to 20x. Here's the equation of a parabola that meets these conditions. Let's do one more. Example 3. Okay, let's say has the directrix. The line x equals 2. This is the equation of the directrix. Let me go ahead and pause the video and see if you can come up with the equation of this parabola here. Okay, let's do it. Let's draw a picture. Okay, the directrix is the horizontal line, x equals 2. Okay, so here's our directrix. Okay, we know that the parabola has its vertex at the origin. Okay, so in this case here, since this is a point on the parabola, the focus is actually going to be to the left of the directrix. Okay, so this will be the point -2, and this is where our focus will be. So our focus has coordinates -2 and 0. So our parabola is going to open up like this. It'll open up to the left. So right off the bat, we know this will have the equation y squared equals 4px. Okay, in this case here, we could kind of almost read our p-value from the focus. Here the p-value, p, will be -2. Or you could think that the distance from here to here is 2. And since the focus is to the left of the directrix, we'll write -2 for our p. Okay, so we'll have that y squared is going to be equal to 4 times negative 2x. So y squared will be equal to negative 8x. And there we have it. Okay. Let's now talk about parabolas that are shifted. Okay, shifted parabolas. So what we want to do is we just want to shift the vertex of the parabola away from the origin. Okay, so let's do an example. Let's say that we have the parabola x squared is equal to 8y. We could do just a loose sketch of this one here. Okay, the origin or the vertex will be at the origin. Okay, if you take 8 and divide it by 4, here we know that p is going to be equal to 2 in this case. So let's put 2 here and negative 2 here. Okay, I guess I could go out here 4 and out here negative 4, going at a distance of 2p. Okay, this will be our parabola. Okay, it's at the origin. Okay, what we want to do is let's shift this away from the origin. And maybe what might help us is to not look at this as x squared is equal to 8y. Usually we're used to seeing like y is equal to something. So let's say that y is equal to, how about x squared? Let's do x squared all over 8. Now let's go ahead and shift the parabola. Okay, let's move the vertex to, let's say, the point 2, 3. Okay, so let's sketch this really quick. Okay, so we're moving the vertex to 2. So here's 2. Here is 3. Okay, so this is where the vertex is. Okay, now where's the focus going to be? Where's the focus going to be? Well, I need to go 2 units up from the focus. So here's 5. So this is where this is where the vertex is. This is the focus. Okay, and the directrix will be 2 down. So this is where the directrix will now be. So I guess we could go over 4 units. 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, so here's our shifted parabola. Okay, I want to go over 4 units. 1, 2, 3, 4. I should be at negative 2. Okay, here we go. There we go. That's better. Okay, so here's our shifted parabola. Well, what did we do to it? In terms of transformations, we've shifted the graph. This graph to the left 2 units, and we shifted it up 3 units. Okay, well, how do we do that with transformations? Well, what we would do is we would take our y, and if we're shifting it to the right 2 units, I am going to subtract 2 directly from the x value. Okay, so now I've shifted this graph to the right 2 units, and now I want to shift it up 3 units, so what do? We would normally add 3. Okay, but let's say I kind of go backwards and kind of get it kind of in this form here. I'm just going to subtract 3 from both sides. You'll see kind of why I'm doing this here in a second. So here we'll be left with a y minus 3 is equal to an x minus 2 squared all over 8. Okay, now let's multiply both sides by 8. Let's multiply both sides by 8. So we'll have that 8 8 times a y minus 3 is going to be equal to a x minus 2 quantity squared, or I'm going to write it up here, erase some of this. We'll have the equation x minus 2 squared will be equal to 8, and now we'll have a y minus 3. Okay, so this is the equation of this parabola, except I just moved its vertex to the coordinates 2, 3 rather than 0, 0. But now, kind of notice what's happening here. When we take our x value and subtract 2 from it, we're subtracting 2 directly from the x value. That's moving the graph to the right 2 units. And here, when I'm subtracting 3 directly from the y value, this shifts the graph up. This shifts the graph up 3 units. Shifts the graph up 3 units. Okay, this will now hopefully help us generalize on how to shift a graph. If I add a value, if I subtract a value from the x value, if I'm subtracting 2, that's going to move the graph to the right 2 units. If I was adding 2, it would move it to the left 2 units. Here, if I'm subtracting 3, that's going to move it up 3 units. If I was adding 3 directly to the y value, that's going to move it down 3 units. Okay, let's write this all down. So whenever you have an addition or subtraction that's directly affecting or directly attached to the variable, it kind of works opposite to your intuition. Sometimes when you think plus, you think right, you think plus, that's up. Okay, but if you're doing those operations directly to the variables, it does kind of like, I guess, opposite of your intuition. So let's say we have some sort of shift. Let's say we have a shift, and then we have a replacement. A replacement. Okay. So let's say if we want to go, let's say we want to go right h units. If I want to take a parabola, I want to shift it right h units. In this case, we're going to replace x. X is going to get replaced with x minus h. This is the replacement. If we want to move it left h units, we're going to replace x with x plus h. Okay. If we want to shift the graph up k units, what we do is we replace the y. We replace the y with y minus k. If we want to shift it down k units, we're going to want to replace our y with y plus k. All right. Let's do some examples. Okay, let's go ahead and try to graph this shifted parabola. Go ahead and pause the video and give it a shot. Okay, the first thing I think I want to think about is, where is the vertex located? And then we'll base all our measurements from there. Well, since we're adding 1 directly to the x value, this is saying that we're going to be shifting the graph left 1 unit. Here, if we're subtracting 3 directly from the y value, that's going to shift the graph up 3 units. Okay, so, well, the vertex used to be at 0, 0, and then after the shifting, we've shifted this left 1 unit, so the vertex will now be at the coordinates -1 and 3. Now, the other thing we need to think about is, what is the p-value? Okay, we can still get our p-value. See, from this number multiplied out front. Okay, so maybe I should write down kind of the general equation of a shifted parabola. So it'll be x minus h squared will be equal to 4p times y minus k. Or Can't remember if I'm getting my H's and K's mixed up. Yeah, that's fine. Okay, or we could have y minus k squared will be equal to 4p times x minus h. These will be one of the two versions of a shifted parabola. So we can always still look at the coefficient in front of the y minus or y plus piece, and that'll still be our 4p. So here we have that 8 will be equal to 4p, or we have that p will be 2 if we divide both sides by 4. This is all we need to graph our parabola. So let's go ahead and sketch it. Okay, the vertex will be at -1, 3. So here's -1. Now let's go up 3 units. Okay, so this is where our vertex will be. Maybe I'll put a V here for vertex. And now, since we have a x piece being squared, this is either going to be a happy face or a frowny face parabola. But our p-value is positive, so it'll be a happy face parabola. So now, let's go up. Let's go up 2 units from the vertex. So here's 5. So this is where our focus will be. Our focus will have coordinates. Looks like -1, -1, and 5. And where will our directrix be? Our directrix will be 2 units down from the vertex. So here's the directrix. Okay, the directrix will have equation. What will this be? Y equals 1. Y equals 1. That's the equation of the directrix. Okay, now let's mark the endpoints of our focal diameter. Okay, well, P is 2. Okay, so I want to go 2P to the right of the focus and 2P to the left of the focus. So 2P will be 4, so we need to go 4 units to the right. So 1, 2, 3, 4. 4 units to the left. 2, 3, 4. So this will be at -5 and 3. So we have this point will be on the parabola. And we have this point here will be on the parabola. This will have coordinates, what? 3 and 5. The coordinates here will be -5, -5, and 5. So we can sketch. We can sketch our parabola. And here it is. Okay. Let's do another example. Okay, let's say we have the parabola. How about y plus 2 squared is equal to, how about 16? How about 16x, let's say, minus 64. Go ahead and pause the video and give this one here a shot. Okay, let's do it. Okay, we want to be able to recognize where the vertex of our parabola is. Now, the problem is that we have 16x minus 64. This is not going to be a parabola shifted to the right 64 units. That's because I'm subtracting 64 directly from 16x. I want to know what's directly acting on x. So we actually need to factor first. So we should write this as y plus 2 squared is equal to, let's factor out a 16. If we factor out the 16, we'll be left with x minus 4. Okay, so let's see what's going on here. Okay, so we're adding 2 directly to the y value, so that's going to shift the parabola down 2 units. Okay, here we're subtracting 4 directly from the x value. That's going to shift the graph right 4 units. Okay, so the vertex used to be at 0, 0, and now the vertex is going to be at, what, 4. I'm shifting it to the right 4 units and down 2 units. So 4, -2. Let's also figure out what our p-value is. Okay, So in this case here, P is going to be the same thing as, or 4P will be the same thing as 16. So P is going to be equal to 4. Now let's also think about the orientation here. Well, the y is being squared, so it's going to be either a parabola opening up to the right or to the left. Our p-value is positive, so it's going to be opening up to the right. Okay, so let's sketch it. Here's y, here's x. Okay, so our vertex is at 4, -2. So here's 4, here's -2. Okay, this is our vertex. Okay, where's our focus? Well, this is saying that we need to go to the right 4 units from the vertex. So 1, 2, 3, 4, so we'll be here at 8. I think I might need to shift our graph up a little bit. Don't have much room here. Okay, let's actually do this. So here is x and here is y. Our vertex is at 4, -2. So this is where our vertex is. Maybe I'll put a V there. I need to go to the right 4 units. So now we'll be at 8. So this is where our focus will be. Our focus will have coordinates. Our focus will have coordinates, what, 8, -2. Okay, we need to go backwards 4 to get to our directrix. If we go backwards 4, we're right at the, right on the y-axis. So this is the directrix. This is the directrix, and it'll have equation, let's see, x equals 0. Okay. So what do we need to do now? We need to figure out the endpoints of our focal diameter. So from the focus, we need to go up and down 2p units. So we need to go 8 units up and 8 units down. So so I need to go an extra 6 units. 1, 2, 3, 4, 5, 6. Okay, so this will be a point on our parabola. Looks like I still don't have quite enough room. I need to go 8 units down. Okay, just for the sake of my board space, so -2, 1, 2, 3, 4, 5, 6, 7, 8. So now we'll be at -10. This will be the other point on our parabola, and now we can sketch it. So here's our parabola. Okay, let's label these points here. This will have points 8, 6, and this will have points. This will have 8, -10. And our vertex is at 4, -2. And there we have it. There's our parabola. Let's do some examples where we're given some information about a shifted parabola and we want to find its equation. For this example, I want you to try to find the equation of a parabola that has its focus at coordinates -3, -4, and its vertex has coordinates -3, 2. I also want you to try to find the equation of this parabola's directrix. Pause the video and give it a shot. Okay, let's do it together. The first thing I'm going to do with any of these type of problems is I want to know, is the parabola, up and down, or is it left to right? There is one version of the equation where the parabola is smiling and frowning, and there's another version where the parabola is to the right and to the left. Now, which ones those are is going to depend on where the focus is in relation to the directrix, and that'll tell us whether our p-value is positive and negative. Before we do too much, what we really just need to do is figure out how this parabola is oriented. So let's just sketch these features. We don't need a precise graph. I just need to plot enough information to get an idea of what's going on. Okay, so let's see. The focus has coordinates -3, -4, so I don't know, roughly go over here, -3 units. We're going to go down, I don't know, roughly -4 units. Okay, so this is where our focus is. Okay, and the vertex has coordinates -3, 2. So I don't know, this is roughly 2. this is where the vertex is. So maybe I'll put a V. The vertex is -3, 2. Awesome. So the first thing to notice is that, or the first thing to remember is that the focus will always lie inside of the parabola. So if this is where the vertex is, this will be, I guess, the highest point or the maximum value this parabola will have. And since the focus has to be inside, this parabola is going to have to be facing downward. So the parabola will look something like this. This isn't an exact sketch, but the parabola is going to be oriented downward. So this tells us that the equation will have the form. Let's see, this will be x minus h squared will be equal to 4p times y minus k. Okay. The h and the k tell us about the vertex, so we actually already know those values. Okay. The vertex has coordinates h and k. Okay, well, since the vertex has coordinates -3 and 2, we know that h has got to be -3 and k has got to be 2. So we can fill in those two spots. The only thing that we don't know is we don't know what our p-value is. Now, before we do anything, let's notice, or let's think to ourselves, is the p-value going to be positive or negative? In this case, it's actually going to be negative. If we think about where the directrix will be, the directrix has to be up here. The focus will be below the directrix. So that means the p-value will be negative. But what the p-value is, it also tells you the distance between the vertex and the focus. Okay, so what is this physical distance? This value will be p. I guess it's negative, so we can maybe put absolute value of p. Well, let's try to think about what this distance is. Well, from here to here is 2, and then from here to here is 4, so this total distance must be 6. I guess you could try to find, if you want to find the distance between these two, you could also subtract them. You could say, oh, we have a 2, and we want to take away a -4, so that'll be 2 plus 4, or we're going to get out 6. So the absolute value of p here is going to be 6. Doing absolute value because this distance here is 6, but the p-value will be negative, again, because the focus is below the directrix. Okay, so we know that p is going to be -6. So filling this all in, the equation of the parabola will be x minus, our h is -3, so x minus a -3 squared will be equal to a 4. Our p is -6, and we have a y minus k is 2. So it looks like we're going to get a x plus 3 squared will be equal to a -24 times y minus 2. This is the equation of the parabola. Okay, the other thing the problem wanted to know is what the equation of the directrix will be. Well, the key thing to know is that the focus and the directrix have the same distance from the vertex. So if we went from the vertex and we went down 6 units to get to the focus, we could start at the vertex and then we could go up 6 units to get to the directrix. So we're at 2, we need to go up an additional 6 units. So we need to go up another additional 6 units. So 2 and 6, that'll put us here at 8. So here is our directrix. Here is 6. Okay, I'll just leave that there. Okay, what is the equation of this line? Well, this is a horizontal line. So this will be y. It says no matter what the x value is, the height or the y value will always be 8. Here's the equation of the directrix. Let's try this next problem. I want you to try to find the equation of a parabola that has a focus at coordinates 5, 4, and the equation of its directrix is x is equal to -2. Pause the video and give this a shot before we do it together. Okay, let's do it. First thing I'm going to do is I'm going to sketch these features to try to figure out the orientation of the parabola. Is it up and down, or is it right and left? let's first plot the focus. The focus has coordinates 5, 4. So roughly 5 units to the right, roughly 4 units up. So the focus will be right here. Put a little F. Okay. And the directrix is the equation x equals -2. So let's mark -2 on the x-axis. I don't know, this is roughly -2. Okay, this will be the equation of a vertical line. This is saying regardless of what y is, the x-coordinate will always be -2. So this will be a vertical line. This is the directrix. Okay. So the key part to this problem is to remember that the vertex of a parabola lies halfway between the focus and the directrix. So it has to be halfway between the directrix and the focus, so the vertex, I'm just kind of eyeballing it, has to be maybe roughly right here. So this will be kind of where the vertex is. And if we remember that the focus always lies inside of the parabola, this should be telling us that the parabola should be opening up to the right. Okay, so this is again just a rough sketch of this parabola. Okay, so it's got to be doing something like this. Well, an equation of a parabola that opens up to the right, this is when the y is being squared. So it'll be a y minus k squared will be equal to a 4p times x minus h. So we need to figure out what the coordinates of our vertex is. That'll be the h and the k. And we need to figure out what our p-value is. The p-value is the distance from the vertex to the focus, which is the same as the distance from the vertex to the directrix. So which of these you find first doesn't matter. But I know that distance from here to here will be p, and the distance from here to here will be p. And I also know that this p-value is going to be positive because the focus is to the right of the directrix. If the focus was on the left of the directrix, the p-value would be negative. Okay, so I guess which one do we want to find first? It's really kind of up to us. Let's find the coordinates of the vertex first. Okay. The first thing to know about the vertex, at least from this picture, is that the vertex has the same height as the focus. That means that the vertex and the focus will have the same y-coordinate. So I know that the y-coordinate of the vertex will be 4. But now we need to figure out what is the x-coordinate. And since the vertex lies halfway between the directrix and the focus, I need to figure out the x value that's halfway between -2 and 5. So how can we figure out a number that's between -2 and 5, or well, not a number that's between them, but I want to know exactly the number that's halfway between -2 and 5. What we can do is we can just average those two numbers. So let's take 5, and let's add -2, and then let's cut that in half. So we're finding the average of 5 and -2. So this will be what? 5 take away 2, that'll be 3. 3 divided by 2, or 3/2. This x-coordinate here will be 3/2, so the coordinates of the vertex are 3/2 and 4. Okay, this tells us that the graph has been shifted to the right 3/2 unit, so our h will be 3/2, and it's been shifted up 4 units, so our k here will be 4. Okay, now let's try to figure out what p is going to be. Well, there's a couple ways we could do this. I guess before you found the coordinates of the vertex, you could have, figured out the distance between -2 and 5. So this physical distance here, well, we could have counted, I guess. Well, from here to here is 5 units. From here to here is 2 units. So this is a total of 7 units. Or you could have taken the number 5. When you find the distance between two numbers, you subtract. So 5 take away -2, well, that's 5 plus 2, or that's 7. So 5 and -2, they have a distance of 7 from one another. Okay, and then this is 2p. So this would be 2p. Or, I guess now, we just want to figure out what p is, so we can divide both sides by 2, so p will be equal to 7/2. Another way you could have done this is you could have figured out the distance between 5 and 3 halves. So this may be a great way to check your work. P will also be 5 take away 3 halves. Okay, we just got to do some fraction subtraction. So 5, let's write that with a denominator of 2, so you can multiply it by 2 over 2, or you could realize that 5 is the same thing as 10, cut it in half, or 10 halves, minus 3 halves. So 10 halves take away 3 halves is 7 halves, which is exactly the same answer that we got. Beautiful. So our P is 7 halves. Now it's all just about throwing it into the equation. So let's make ourselves some room here. Okay, so the equation of the parabola will be y minus 4 squared will be equal to 4. Our P is 7 halves. And then we'll have what? An x minus 3 halves. X minus 3 halves. Let's maybe clean this up. This would be the same thing as y minus 4 squared will be equal to, if I do 4 divided by 2, that's 2. 2 times 7 is 14. So 14 times x minus 3 halves. And here we have it. This is the equation. This is the equation of this parabola. That's all I have for this video here. In the next section, we'll be learning about our next conic. We'll see you there. Take care.